at 11:30, so we are going to crack on with our third and final presentation for today. And we have the team at Brits Energy to give us a slightly different type of project, but equally interesting. So I'll hand over to the team now for presentation, and as with before, please put your questions in the chat and we'll field them at the end. Thanks very much.
Okay. Thank you very much, David, for having us here today. Before I start, I would like to say thank you to Energy System Catapult team for their hard work and support during the past 3 months, especially Fabio, who has been as a star of the show for us. My name is Ahmad, CEO and founder of Brits Energy. Formed in 2018, we are a small company focused on providing utility using innovative business model. Over the past 2 years, myself and my team engaged with indoor farming sector to help them overcome the challenge of energy cost and associated CO2. The agenda for the next 20 minutes is to provide an overview of the business opportunity, what have been achieved in phase 1, and a quick run through of the alpha, and finally conclusion. As the other earlier sessions, there will be 10 minutes for Q&A at the end, but if we don't get around to answer all of your questions, please feel free to send your question to NZOM@britsenergy.co.uk, and we will address them outside this session. Okay, to better appreciate the opportunity, I would like to set the scene and talk about some of the facts around agriculture supply chain. Currently, agriculture is one of the main influencer of the climate change, and at the moment it's accounting for 1/4 of the greenhouse gases and uses 2/3 of the fresh water. The food production capacity is set to go under further pressure to cope with this estimated global population increase by 2 billion by 2050. So to achieve the food security and net zero emission target by 2050, a transformation is required in agriculture sector. Total control environment agriculture, i.e. vertical farm, as some may have the term, has the ability to increase food production capacity to feed the population within the specified constraints. And the key benefits are local sustainable food production with 99% less land and 95% less water requirement, reduced dependency on import by producing locally all year around, and minimize environmental adverse impact by reducing the need for transport, storage, and pesticides. And last but not least, significantly less waste resulting from better control over supply to meet the demand. Adoption of TCEA, Total Control Environment Agriculture, can put UK in the forefront of sustainable and clean growth by increasing production capacity, reduce reliance on import, and minimize adverse environmental impact of producing fresh food. TCEA has a significant market potential, but cost of energy to replace the sunlight through LED and maintaining the growing environment act as a barrier for its uptake. NZOM is aiming to utilize granular control and monitoring capability in TCEA farms in conjunction with the plant's ability to accommodate the changes in the environment in order to reduce the energy cost by 30% and associated CO2 by 100%. On energy side, changes in regulation is encouraging deployment of renewable generation to address the increased demand coming from electrification of different industries such as transport and heat and agriculture. But inherent intermittency nature of the renewable generation makes the balancing of the supply and demand more difficult. In year 2020 alone, National Grid incurred £1.6 billion to balance the supply and demand. And it is predicted by 2025 wind curtailment between Scotland and England will cost consumer £1 billion per year. So a lot of surplus clean generation to take advantage from. So the opportunity is in plants' ability to store energy in order to accommodate the changes in the environment condition within reason. So, and that basically is the plant's underlying capability to continue its growth, even in cloudy days, with higher or lower irradiance, airflow, temperature, and humidity. So the idea is to utilize this capacity to reduce total cost of electricity through load management and load shifting. Our vision is to enable deployment of TCEA while enhancing grid resiliency. NZOM is a solution which will help reaching net zero efficiently, effectively, and at the lowest cost, as it mitigates the impact of wider changes in the energy system. Our approach was welcomed by customers as it offers a realistic roadmap to meet the sustainability goals in an affordable manner. The key objective of NZOM Phase 1 was to validate the approach to reduce the total cost of clean electricity for TCEA operation by understanding their operations flexibility and then identify the best location in UK map to utilize the identified flexibility to reduce cost and CO2. As you see, we are looking to bring the information from TCEA, including demand size, level of flexibility, and operation growth plan. Then take a look at the energy ecosystem to identify a location with the best opportunity based on surplus clean generation capacity, need for flexibility, distribution network headrooms, connection costs, DSR programs, and other variables to maximize the value from the available clean capacity in order to reduce the total cost of electricity for TCEA operations, while serving other energy system users with on-site clean generation capacity. To achieve the objective of Phase 1, we have teamed up with different stakeholders in TCEA sector, such as technology developers and growers, to understand their pain points and develop a usable solution to address them. Our early engagement with customers was instrumental to better understand other elements that influence their decision-making process when deciding on location for their operation. While energy is a very important element for them, other matters such as proximity to consumers, other infrastructure access such as road, land price, air and water quality impact their decisions as well. To ensure we develop a customer-accepted solution and avoid the risk of incorrect presumed assumptions, we adopted double diamond framework in Phase 1. With close collaboration with the customers, we conducted discovery phase to understand their issues, then defining the requirements to address them, followed by developing ideas to meet the requirements, and finally gone through development and improvement iterations to build the alpha. In Phase 1, we have invested heavily in user discovery, creating personas, and defining the user requirements before starting the actual alpha development. To minimize the risk of design failure, we have reviewed other proven recommendation-based platform in other industries and tried to learn from them to create an acceptable user experience. 6 use cases were defined, leading to developments, build and approval of 11 core features in alpha version of NZOM. Based on cost and CO2 performance, NZOM outputs its results in a red, amber, green location on UK map. Customers were at the center of our Phase 1 development, and project team conducted 29 workshops to facilitate development of the 11 core features with 39 enhancements, as well as fixing of 33 bugs as part of the 5 improvements iterations. In order to create the red, amber, green color-coded map, illustrating the energy cost and carbon emission of each region, within the UK, we needed to develop 3 types of analytics engine using machine learning algorithm. The tool's inputs are data related to the energy cost trend, carbon intensity, and operations flexibility and constraints. The output would be an optimized load profile and energy input scenarios from different sources to ensure the energy cost and carbon emission of the operation is at its minimum. Also, available flexibility programs to generate revenue will be an output of NZOM. As mentioned, NZOM requires 3 inputs to generate color-coded map. Future energy cost. We used MUK ERC method to generate regional energy cost, considering DNO-related costs and availability of renewable resources. And as different types of data is required to build this model, we defined and classified components and identified data providers. Regional renewable capacity and available flexibility programs are other important parameters in MUK ERC method. Second is the CO2 emission performance. For phase 1, we adopted a simple forecasting model using historical data and different carbon offsetting strategies. In addition to that, in order for the model to be able to have a future forecasting capability, we looked at future energy scenarios published by National Grid as a guideline to understand how things will move toward net zero, depending on different scenarios. And lastly, optimized load profile, which takes advantage of the operations flexibility to respond to the energy system dynamics. This will include hours of required lighting, temperature, airflow flexibility to reduce or increase the demand. Key consideration is to manage the demand without affecting the quality and the level of operations output. The optimization model need a trade-off between quality and quantity of the crops and revenue generation from flexibility program. I have asked my colleague Yayu to prepare a demo video to take the audience through the alpha prototype developed during phase 1. And if you bear with me, I will share the video.
Hi everyone, I'm happy to present you the alpha version of NZOM and show you how it helps users to identify the best operation location in UK. On the landing page, you will see a search box. There are 2 options to do the research. First option, users can enter postcode or region's name to narrow down their search. Learning from the end users, we know that before location research, they already have an area in mind. Second option is for users that are just browsing location information across the whole UK. In this case, they can just leave it blank. After this, users need to input their farm information. This information will be used to calculate the energy cost and the associated CO2 emission level in different locations. First option is for users who have a general idea of crop type and farm scale they are looking up to set up. They can choose multiple crop type and production volume here. For example, for a farm that are growing 600 tons of strawberry and 300 tons of basil, they can enter like this. In the back end, based on some educated assumption, NZOM calculates the energy consumption and flexibility based on the crop type and production volume you choose. The second option is for more knowledgeable users. It's likely to be a TCEA technology developer who know clearly their energy consumption profile and the breakdown per component. User can enter a detailed information of HVAC, lighting, or others here. We would like you to also enter the information about your capacity and the flexibility. You can see the explanation for each box. For example, flexibility percentage here means to what extent the unit can reduce its demand to participate in the flexibility program, which can give you extra revenue. It's important to know if users are planning to have an EV fleet as part of their net zero journey. In NZOM, it also affects the capacity and flexibility of the overall operation. Here, let's use a simple example of 600 tons of strawberry. Also using EV. After we enter location and farm information, we come to the main map page. Because we leave it blank on the landing page, the map shows 14 license area here. Different color means the energy cost and CO2 emission level. Green being the best option for us. It means the user can have the lowest energy cost and CO2 emission compared to the neighboring area. Amber being the second option, red being the worst option. If users want to narrow down the research, they can type in a postcode area here. For example, TA6. And we will be able to see the location information under TA6. This including energy cost per annum and CO2 emission level. It's also very important for users to know how long and how much does it take to connect to the grid. We know that users are also very interested in knowing how to generate extra revenue. That's why we show users the available flexibility program in DNO level and national grid level. We know that a lot of users are trying to be green in their operation. That's why we also would like to show the user how easy it is to find renewable generator and EV charger in this area. At the same time, the available incentive program are listed here, and also about air and water quality. If the user want to see the initial input, they can open the filter here. When zoom in and zoom out, or dragging the map, user can see the surrounding area. The color of the area will change according to the area visible in the window. So user can see how well TA6 perform compared to the surrounding area. When there is an exclamation mark in an area, it means getting a connection might take more than 6 months. Back to TA6. If user want to see more detail about this location, they should click for information to see the analytic page. Analytic page is designed for users who want to know how the farm scale and flexibility will affect their bill and carbon intensity. User can adjust the forecast period, farm scale, energy capacity to see what's its impact on the output. For example, the larger the capacity, the higher the cost. And also, the higher the flexibility you have, the more revenue you're going to generate from the flexibility program. User can also see what is the best energy mix for their operation. If the user enter crop type and farm scale at the beginning, they can see what is the assumption behind the calculation. And very important feature here is location comparison. All the information here is about the location TA6. If you're choosing to decide between TA6 and TA5, you can click this button, choose TA5, and you can see clearly the whole picture, how TA6 is performing against TA5 and against the UK average. And at the same time, we can see all the number here is about Brits Energy solution. Compared to a non-optimized way, Brits Energy solution can help users to save 30 to 40% on energy costs and CO2 emission. After some change on the slider, user can go back to the map and begin another round of research. If users are already happy of the result, they can export the result to a PDF and save. That's the end of the presentation. Thank you very much.
Okay. Right. Okay. So I hope that everybody enjoyed the demo, and here I think I'm coming to the conclusion. So in conclusion, I would like to say that one of the key outcomes of our phase 1 development is reaffirmation of the fact that significant value can be generated by enabling access to data, and net zero cannot be achieved without it. The specific challenge for NZOM development is not only access to data, but understand the operations capability to flex demand to match the energy system dynamics. While we continue our engagement with energy sector stakeholders to access the required data, we will go into phase 2 with our customers to enhance our understanding around their systems and operations flexibility. Furthermore, quantifying impacts of social, legal, political, and economical elements are proven to be very challenging. Our approach to accommodate these are to engage with likes of BASE, Ofgem, Elexon, and then make sure that we are fully aware of the forthcoming changes with the impact on energy cost. And for the closing thought, I would like to quote Tom DeLay, Chief Executive of Carbon Trust, who said, flexibility is vital to unlock value, and it is the most important no-regret action that can be taken as the UK moves to decarbonize heat, transport, and industry, saving billions in investment and operating costs. Thank you very much for your attention, and we are happy to take your questions.
Brilliant, thank you very much. So there have been a few questions in the chat. So the first one that came in was, there was a number that you quoted early on in the presentation, 50 billion. The person asking the question asked, is this a market potential figure for global or national?
That's a global market potential, but it's worth mentioning that that's the potential, but with the current barriers that this sector has in front of them, and the key one being electricity, as mentioned in the slide, is contributing to 50 to 70% of the cost of goods sold. There is a risk that that potential may not be achieved. But that figure, to answer the question, is actually a global figure.
Okay, brilliant. And we've just had another question come in that says, do we know what the size of the market for TCEA is in the UK specifically?
Yeah, in the UK, it's very interesting questions, and whenever we go to size this market, there is all sorts of different arguments around it. With the fact that we can size the market with the potential for size the market with the barrier or without the barrier. If we address the barrier, the market size is quite immense. In one of the projects that we are involved in, we are working with the several agriculture stakeholders, and we are developing a strawberry farm. Looking at that market alone, it introduced 2.5 billion. So that's only one crop, one market. So if you want to bring all sorts of other things, it's not out of reach to think around 20 billion pounds market for UK. But as I said, it's with the caveat that the barriers are addressed. But we couldn't find any specific report which quantify the market of TCEA for UK.
Okay, great, thank you. So there's been a number of questions that are along a similar theme. So we have, do flexibility payments dominate the business case for the grower, or is it considered upside revenue outside of their core business case?
Yeah, sorry, go on.
No, carry on. You answer that one first and I'll add.
All right, okay. Very good question. And I'm glad I have Dr. Gareth Jones from Digital Farming, who are a partner into this project. So because it's related to them, I'll leave it to Gareth to address.
Thanks, Ahmed, and thanks, Richard. Yeah, it's both really. It can be considered upside where there's existing commercial cases that allow you to operate right now. But it's also can enable commercial situations of profitability where the current sort of energy costs prohibit those things. So it's really all linked to what Ahmed said, really, around it's a barrier and a moving barrier, and the moving barrier allows us then to consider new businesses where this type of DSR implementation in DSR services allows us to be able to forecast lower energy costs across a long-term situation, and also increase profitability of existing growing elements. So it's both, and also I believe, you know, as somebody that's looking at growing crops right now in this area, it also allows us to begin to participate as part of a microgrid structure, which we believe through a sort of more circular economy, sort of integrated approach, will allow, you know, through participation with other consortia, to be able to benefit more in terms of the profitability of our businesses.
Okay, brilliant, thank you. And in terms of the DSR programs that are available and that the Brits Energy solution could be used with, do you have an overview of which DSR markets or DSR solutions you might be able to contribute to?
Yeah, David, do you want to address the question, please?
Yeah, I'll quickly answer that one. At the moment, we'll be predominantly bidding into the DSO local markets, just because of scale. And then there's absolutely no reason why, through aggregators to start with, we couldn't go into the ESO flexibility markets as well. So it just depends on scale, to be honest with you. So once we get a volume going, then we can do either.
And I guess one thing that I think worth mentioning is, depending on the requirements of the program and how much notice it gets, and the fact that by what kind of ramping rate and response time coming as part of the requirements, we can participate in different types. And the fact that we are always thinking to have a means of on-site storage, so a battery pack, which could then facilitate participation in different type of programs and act as a buffer, would be quite helpful.
Okay, brilliant, thank you. So there's another question around carbon consumption. So how should whole life carbon consumption be considered in data analysis? The UK carbon consumption is approximately 300 megatons of CO2 on the 500 for operational emissions.
Okay, I think the question, it's a really good question. If I understand it correctly, there are two elements of the carbon. One is embedded carbon emission, where you set up a facility which comes with the capex, and one is the operational CO2 emission part of it. So in NZOM, our kind of objective is to minimize the CO2 emission associated with operation of the farm, and that's mainly coming from the fact that the energy consumption is the key contributor for these operations. So if we can address the CO2 emission associated with the energy, we are kind of addressing the operation CO2. On the embedded CO2 of the operations themselves, we are also looking in other projects we are engaged with the sector. We are looking and we are conducting life cycle analysis to then understand what would be the total CO2 emission as a result of that operation throughout the whole life cycle. And then considering mechanisms such as carbon offsetting, and also because we are growing plants, naturally it does sequester carbon from the environment. But again, TCEA is a very is going through its early phases, so there is not much of information to say how much CO2 sequestration is taking place. I don't know, a ton of strawberry production. So these are ongoing studies that we are looking at to address all of those concerns.
Okay, brilliant, thank you. And then we just had one final question come in from, which links back to another subject that we were talking about. So the UK's ESO grid balancing need is finite and is currently oversubscribed, which is forcing down the price per megawatt of flexibility. Have you factored this into potential business cases, or do you expect this to change? So essentially, the value of flexibility today may not resemble what it is in the future. It may go up or down. Has that sensitivity to be included in your business case?
Very good question. And as I mentioned in my last slide, there are elements which are affecting those calculations, which is very hard to quantify. Elements of economy, environmental, legal, regulations, and all of that. So it's a moving target that we have to adjust based on where we are standing at the moment. But the way to make sure that we got the most accurate calculation, because that's very critical, is to engage with the sector and try to optimize our forecast as much as we can to accommodate the deviation, which I should say is guaranteed to be the case, is to have an insurance mechanism in place. But by having on-site generation to then accommodate those variation, and also onboarding other stakeholders from energy system. Because, for example, if we can bring ESCO companies to come and invest on the on-site generation, basically they are taking some of the risks. So sharing the risks and then have insurance mechanism in place to address those. But from my point of view, I shouldn't think that we could accurately, when I'm saying accurate, I mean 100% accurate, say what's going to happen in the next year, because these programs, as Lee said, is currently changing constantly, and we don't know whether it's going to get more value or less value.
Brilliant, thank you. So that takes us to the end of our questions section for this. So just again, another big thank you to everyone who contributed on the question side, and thank you to the Brits Energy team for the presentation. If you'd like to get in touch with Brits Energy or any of the projects that you've heard about today, please either reach out to the Catapult or use the contact details that were shared throughout the slides. But otherwise, just thank you very much for your time, and thank you to all the presenters. Have a great day.
Thank you very much.